Okay, this is screencast 2 for CO1A. And I apologize in advance, my printer wasn't working, so I drew out all the graphs. My position graphs are going to be in the black pen, and my velocity graphs are going to be in the pink highlighter. And where I'm going to show you what's going on, this is going to be it. This is my origin, to the right is positive, and then to the left is negative. So for the first graph is the position versus time graph is a positive sloped linear line with a consistent positive slope. So that means the velocity is constant as well, and it's going to be a constant positive velocity. So right here in this pink line shows you the positive constant velocity. So what this graph is going to look like is it starts negative, heads towards the origin, and then continues off positive. But, like I said, the slope is constant the whole time, so the velocity is constant. So what it's going to look like is it's going to start at the negative, it's going to head towards the origin, and then continue positively at a constant velocity. The next graph looks like this. So the position graph is going to be this constant horizontal line in the positive direction. So it's above the origin, so it's positive, and it's constant. So because it is constant, that means it's not going anywhere. It's staying in the same position. So that means the velocity is going to be 0. So it's a constant 0 velocity. So what this is going to look like is if this car was in the positive, I'm sticking out, fell off. It's going to be in the positive position, and it's just gonna kind of just stay there. It's not gonna move. Then the next graph is going to be this. So this is the position graph. So it is a constant negative sloped line. So it's kind of like the first one we did. So because it is a constant slope, the whole graph, but it's negative, so the velocity is going to be a constant negative velocity. So this one starts positive, heads towards the origin, and then goes off negative, again with a negative slope, constant slope the whole time. So what this is going to look like, it's going to start positive, head towards the origin, and then continue off a little negative, all at a constant velocity. And then the next one is going to be this positive parabolic line. So the black line again is the position. So it is a gradually increasing line, which means the velocity then, which is the pink line, is going to be gradually increasing sloped line. So what that is going to look like over here, because it starts at 0 and it continues positive in the positive direction, gradually increasing. So what it's going to look like, it's going to start at the origin, and then it's going to gradually get faster and faster and faster in the positive direction. And then the next graph is going to be this downwards parabolic line. And usually parabolic position graphs mean that the velocity graphs are going to be linear. So since this is a gradually increasing negative slope, well, it's going to start off fast and then it's going to slow down. So it's going, at this point on the position graph, the velocity is going to be 0 because the slope is 0. So that's why the velocity graph starts at 0 and then continues downwards. So it's going to start fast and then it's going to slow down. So it's in the positive direction it starts, heads towards the origin, and then just goes off a little bit into the negative. So what it's going to look like is it's going to start fast at the origin and then just kind of slow down in the negative direction.